Okay, so what we're going to go over today is how to construct a vertical profile using a topographic map. I have the Mount of the Holy Cross quadrangle, which you've seen in class for Chapter 5. And what we're going to do is we're going to create a vertical profile across Peterson Creek, which is to the northeast section of the map, or the top right-hand corner. And what we're going to do first is figure out where our profile line is going to be. So I'm just going to arbitrarily choose these points that are going to mark off my profile, and on the test these will be given to you. So what I'm going to do is use this hill right here, the 11,161, and then I'm going to stop over here on this 10,400 foot index contour. All right, and I'm going to stop right where the 1 is that starts at 10,000. All right, now for this exercise, I'm just going to mark off the index contours. Your instructor may require you to mark off all all contour lines, but I'm just going to do the index contour lines. All right, now on the test, you'll be given 2 locations on a map, just like I just gave you, that will mark off the ends of your profile line. All right, so the next step is to take a sheet of paper and lay that paper down so that the edge lines up with those 2 points. So here we have the 11,161 top of this hill, and then over here I have the edge of my paper on next to the 1 and 10,400. All right, so that's going to be my profile line. So what I want to do is I want to see what this terrain looks like from a profile view, because right now, looking down on the topo map, that's a map view perspective. We want to see what the terrain would look like if we were standing like in Peterson Creek looking across the horizon. All right, so once you have your sheet of paper down on the ends of your profile line, what you're going to do next is you're going to mark off on the map every time the corner of your paper intersects a contour interval. So let me move in on this so you can see what I'm talking about. All right, so here we go. I'm going to mark off these now. But only make marks for the contour intervals, nothing else, if that's what you're doing. I'm also going to make a mark right here where Peterson Creek intersects the edge of my paper, so I'm going to make a little wavy line. So that's my Peterson Creek. Now I know where the stream is. All right, I'm going to go across the stream and keep marking off my index contours. And then I'll put one more here. All right, and then now what I can do, even with the limited view that I have of the contour values beneath the sheet, I can see that this mark I made here is the 10,400 elevation mark. So I'm going to go ahead and label that. You should put your labels vertical so that you can fit them next to each other. And then I'll mark off any other lines that I can figure out. Like this one over here. This is 10,400 as well, and that comes to this point. All right. And then I can figure out what these other points are on my map just by knowing that since the contour interval for Mount of the Holy Cross is 40 feet, then the change between index contours would be 5 times that, which is 200. So I can see that elevation is decreasing going to the north, because this is 10,400 right here, and this is 10,200. So if I go this way, like this line right here, I'd have to go to a higher elevation by 200. So I'm going to go ahead and do that. I'm going to go ahead and label on my map that elevation value. So this would be 10,000 600. All right, I also notice this is the same line here, the same index contour, so I can go ahead and label this one as well. All right, now this line right here that I haven't labeled is the same one that I labeled over here, which is 10,400 again. So I'm just getting these values off of the map and put them next to the marks that I made on my paper. All right, this line right here is 10,200. All right, I go to the other side of the map, and this value should increase. It's probably the same line. If we flip this up, we'll see. Yeah, it's the same index contour. So I'm just going to put 10,200 on the other side of the stream. All right, we already have 10,400 there. Elevation's increasing going this way towards the south. So this would be 10,600 because it's 200 plus this one. All right, and then I need to add another 200 going this way. So this would be 10,800. And my last mark here is 11,000. All right, so now I have all my values. I have my creek on here as well, so for reference purposes. Now, before I pull the paper away from the map, the next thing I need to record is the orientation of my profile line. Now, I know north is to the top of the map, so if I go this way, it's to the east. So I'm just going to put east over here. You could also use a landform feature if you have one as a way to tell how your profile line is oriented. And if I go this way, that's to the west, so I'm going to put west over here. So now I have the compass orientation of my profile line, east to west, across this map. Okay. Now once I have those values, I don't need the map anymore. Next, what I'm going to do is take my graph paper, and remember, when you look at the graph paper, these bold squares here are 1 inch by 1 inch squares, and they're made up of 10 by 10 little small squares. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 1 inch. And the same thing this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 inch. Okay? Because what I'm going to do next is I'm going to come up with a vertical scale on my vertical axis of my graph paper. Now, I'm going to make this up for this video, but on the test, this is very important, on the test, you must use the vertical scale given to you in the problem. If you don't, you're going to lose 5 points for using the wrong scale. All right, so I'm going to make up a scale just for this problem, but on the test, you're going to use the one given to you in the problem. So let's just say the vertical scale for this video that must be used is 1 inch equals, let's say, 200 feet. Okay, so this is the vertical scale we must adhere to. Now, what I want to look at next is what is my lowest value that I've recorded along this profile line, and that would be 10,200. So whatever I start with down here along my vertical axis has to accommodate the 10,000 mark. All right, so what I normally do is I start with some value lower than that. So let's just start with 10,000. All right. Now remember, our vertical scale is 1 inch equals 2 feet. So I have to make sure that every inch I go up on my vertical scale, the elevation changes or increases, in this case, by 200. So this would be 10,200. All right, next inch up, 10,400, 10,600, 10,800, 11,000, and the highest value I recorded was 11,000. So I can stop there. I've got my vertical scale now. All right, so once you have your vertical scale with your elevations on there, what you're going to do with that sheet of paper that you use to mark your index contours is you're going to place that down along the bottom of the graph paper. It doesn't matter where you put it along the bottom. Just make sure once you place it somewhere, you keep it there. What I normally do is I take this first mark and I line it up with the first bold line of this square. So now I know if someone bumps my elbow or I accidentally move it, I know exactly where I started at. Alright, so now once I have my profile line down here with my values along the horizontal axis, what I'm going to do is I'm going to look at these values that I recorded. In this case, the first one is 10,400. So what I want to do is go directly above that mark and find where 10,400 is on that line. And of course, it's right here. Now, I'm just going to mark that with a dot on my graph paper. Okay? So there's my first dot. So that's directly above the 10,400. And it's right here across 10,400 on my vertical scale. So you want to do this for each one. All right, my next elevation down here, my profile line is 10,600. So I want to find that, go directly above it, and then mark that with a dot as well. Okay, so I'm going to do that for each one. Let me zoom back out here. All right, and then the next one is 10,600 as well. So I'll make a mark for that. Okay, so now I have 3 marks on my graph paper. All right, the next one's 10,400. You go directly above that, find that point right there. All right, 10,200, which is right here. All right, another 10,200 right here. All right, and then over here it's 10,400. Go directly above that. Okay, and then 10,600. Make a mark. All right, now we have 10,800. All right, make a mark. And then we have our last point, which is 11,000. Okay, so that would be directly above it, and will be right here. Okay, so now I've made my marks. Okay, I have a mark on the graph paper that represents every elevation I recorded down here from the index contours. All right, now what I'm going to do is I'm going to go ahead and connect the dots to make my vertical profile. And when I get down here to the stream, because I know that's where the creek is because I put the symbol there, I'm going to make a little V shape. And then probably a good thing to do too is, because this looks like a ridge here, is to make your ridge have a crest. All right, so here we go. Okay, so there's my drawing. All right, and that's the valley that Peterson Creek is in. All right, now what I'm going to do now is I'm going to transfer my compass directions to my drawing. So I'm going to put east on this side. Remember, if you have a landform, you could use a landform instead. All right, so if this hill had a name, you could put the name of the hill on top. All right, and then I'm going to put my west over here. All right, so now we know how you oriented your picture when we grade it. All right, you could also, if you wanted to, put that, Peterson Creek is right here. So you could do that for labeling too. Okay, so what I've done there so far is I have my drawing, I have my labels, and I have the correct vertical profile. This is the first thing we're going to check when we grade your paper. We're going to check this scale, and we're going to make sure you use the scale given to you in the problem. It's not on the map. There's no vertical scale on the topo map. The only scale on the topo map is the map scale or the horizontal scale, and that's at the bottom of the map, and that's 1 to 24,000. That will never change for our maps. That's the first thing we're going to check. So that's like 5 points right there. Drawing the profile correctly is another 5 points, and then putting the labels on here is 2 points. So that's 12 points right there I have so far. Now remember, this question is worth 16 points. Okay, so the drawing with correct scale, vertical scale, is worth 10 points. All right. The labels are worth 2. And then the last thing we have to do is the vertical exaggeration. I just abbreviate that VE. That's going to be worth 4 points, and this is a calculation that you have to do, and you have to show it. All right, so let's go ahead and work out that vertical exaggeration for the last remaining 4 points for this 16-point question. All right, so what we need is the formula, which is vertical scale equals fractional vertical scale divided by fractional horizontal scale. Okay, so let's see what we have. We already have the vertical scale is up here, but this is a verbal scale. You know it's a verbal scale and not a fractional scale because it has units and it has an equal sign. So we have to convert this to fractional scale so that we can plug it into our formula here. All right, so in order to convert this verbal scale to a fractional scale, we have to make it so that it's inches on both sides. So this one already has inches, so I'm going to go ahead and just, this is already in inches, so I'm just going to put 1. And then I'm going to replace the equal sign with the colon. All right, and then I'm going to look at this. This is 200 feet. I want to figure out how many inches that is. So I would just, of course, multiply this 200 by 12. All right, and that gives me 2,400. Now it's a fractional scale. It's fractional because it has no units and it has a colon. So this is the same thing as writing this, a fraction. All right, and that goes in the numerator of our formula here. Now I need the fractional horizontal scale. And if you remember, the fractional horizontal scale of all of our maps are given up here above the bar scales, and it's 1 to 24,000, so that's the horizontal scale, because we use that to measure horizontal distances on the map. And I can go ahead and plug that in just as it is because it's already in fractional scale. Okay. All right, so now I can go ahead and solve the rest of this. So when we divide fractions, what we do is we take the top fraction here and we just bring it down like that, and then we're going to multiply it by the reciprocal of this one. So we need to flip this one. So now 24,000 is in the top, the 1 is on the bottom. Okay, so this ends up being 24,000 divided by 2,400. All right, so you either do this on a calculator in your head, but we know that 24 goes into 24 once. Okay, and then we want to get rid of 2 zeros down here and 2 up here. All right, and what that leaves us is with 1 0, so we keep that, and then we need to put an X here because this is times normal. So this is how much we've exaggerated the vertical profile by using a particular scale and a horizontal scale of 1 to 24,000. All right, so once we've done the calculation, we can go ahead and transfer that onto our profile drawing. VE equals 10x. And that right there is the remaining 4 points, and that gives you 16 points total. Okay? So there you have it, step by step.